Hey everybody, how you doing? I hope you guys were safe during the tornado warning yesterday. Today we're going to be talking about weather patterns. So we've been spending the past 2 days looking at describing weather, making sure we know what terminology and things we use to describe what the weather is like. And we're going to spend the next few days looking at weather patterns. Um, so things that you kind of consistently see happening and why those things tend to happen, such as different types of air masses, um, high and low pressure systems, and fronts. All right, so first we're going to start talking about air masses. So an air mass is literally just a huge, it says body, but think of it as a huge area of air that pretty much is the same temperature and humidity throughout. Now, it doesn't have to be exactly the same temperature and exactly the same humidity, but you could say it's going to be generally cooler air or generally warmer air, not one part of it's hot, one part of it's cold, one part of it's dry, one part of it's moist. It's going to be similar throughout the entire thing. Um, so what determines what kind of air mass you have is where that air is able to stay still for a little while. So there are certain places around the planet where air isn't pushed around by those global winds quite as much and is able to pick up some of those characteristics. So if you have air forming, let's say, over a large ocean, it's going to tend to pick up moisture from that large ocean and be much more humid. Whereas if you had air that was staying still over a large continent, it's going to tend to be drier. If you have an area that's forming over a polar region where it's going to be much colder, it's going to be colder air. And if you had it forming over a tropical region, you can expect that air to be a lot warmer. So these aren't just small little areas of air, but they're massive um, places that sometimes cover hundreds, possibly even thousands of square miles. There are several types of air masses, but each one of them will be defined by its temperature and its humidity or level of moisture. So you'll see that each one of them, the first part of the name kind of tells you something more about the moisture content. So if it's continental, it's going to be dry. If it's maritime, that essentially means ocean water, it's going to be moister. Continental, more dry. Maritime, more moist. Maritime again, it's going to be moist. And then continental is going to be dry. So then the second part of each air mass's name kind of gives you an indication of what temperature that air mass would kind of be. So you could expect Arctic to be really cold. You could expect polar to be, well, probably pretty cold. And then tropical is going to be much warmer. So you can see that if you have continental Arctic air, it's going to be very cold and it's going to be dry. If you have maritime Arctic air, it's going to be cold and moist. If you have continental polar, it's going to be cold and dry. If you have maritime polar, it's going to be cool and moist. If you have maritime tropical, well, it's going to be hot and moist. And if you have continental tropical, it's going to usually be very hot and dry. So when you look at these different types of air masses, we're not impacted directly by all of these types, but there are several that we are directly impacted by here in North America, particularly here in Florida, and we're going to kind of look at that in a moment. All right, so here you see North America. You can see Jacksonville somewhere around down here, and you can see that there are several types of air masses that influence our continent. So we have these maritime polar air masses. These aren't going to be ones that impact us quite as much. We're going to be more impacted by these continental polars and these maritime tropicals. And they're going to be basically usually meeting a lot of times called a front where these air masses collide and causing the weather to rapidly change. So the continental polar air mass, that's going to be continental, so it's going to be more dry, and it's polar, so it's going to be cold, sometimes cool by the time it gets down to us, but when it starts, it's usually pretty cold. And then the maritime tropical air mass, maritime means it's forming over water, and then tropical means it's going to be warm, so it's going to be usually warm, humid air. And if you've been in Florida for a while, you know that we have plenty of warm, humid air, quite a bit. So that's part of the reason why we have that kind of weather around us a lot, is because those air masses are influence our weather quite a bit. All right. All right, so we're going to look at for a second the weather forecast for quite a few days here. So I took this picture yesterday, and we are currently, well, I guess when you're watching this, we're going to be talking about here, but when I made this, I made it right here. You can see that we had some pretty warm temperatures over the earlier part of this week. And then it was predicting it to kind of drop down. So if you were to go back and think about what kind of air mass we had over us, well, it was warm, so it was probably tropical, and it's Florida, so it was probably maritime, and then it cools off. So that probably would mean something along the lines of maybe that continental polar came down and maybe pushed that maritime tropical out of the way, or at least that's what they were expecting it to happen. So we're going to look at some of the weather maps that they were showing, and then we also have a video of the front that went through on Tuesday afternoon / evening and kind of see how this all plays out. So let's go ahead and look at that video. You guys can watch that, and you'll see that throughout just the span of a few hours, the weather changes quite a bit, and it's all a matter of just those air masses basically colliding with each other.
All right, back out here looking at the weather today as compared to the other day. Definitely see some more clouds. I see some dark clouds up there. See some more clouds, whereas the other day it was almost a completely blue sky except for some really high clouds. So what we're looking at here is basically the start of some air masses colliding with each other. We got some warm air coming up from the south. We got some colder air coming from the north, and they are colliding, causing there to be some water vapor higher up in the sky and cooling down. All right, it's been about a couple hours. You can see the clouds have gotten much darker, a lot more of them it seems like, and if you look at the trees especially, they are moving pretty good. That wind is definitely picking up. It's no longer just a little breeze like it was earlier, but you can see the trees are getting blown around pretty good. So once again, that's because these two air masses are colliding, and there's a big difference in pressure between the two, so we have a lot of air moving around to try to kind of fill in the space. And once again, as it's doing that, that cooler air is kind of pushing that warmer air up into the sky. Now it's been a little bit drier than normal here, so we don't have a ton of water vapor or humidity, so we don't have a ton of rain like we would in the summer if this was happening. But we do see we have a lot of condensation up there, and we'll check back in a couple hours and see what it looks like. All right, another hour has passed. And you can see the wind has picked up even more as the can rolls across the ground. And there are way more clouds forming than there were. Darker, covering the sky a lot more. Looks like maybe we see some rain a little bit, so keep an eye out for that. Watching this front as it moves its way through. Alright, it's been about an hour since my last update, and you can see the wind has actually died down quite a bit. But we do have rain. It's not raining crazy hard, but it is raining pretty steadily. So at this point, we have quite enough moisture up in the atmosphere, reaching its dew point, turning into clouds, getting full and full, and eventually precipitating down as rain. So we do see this front is making its way past us. We're probably right over us at this point right now. So in the next hour or so, we'll see what it ends up looking like. Alright. Last update for now. It looks like it's still drizzling a little bit. We had that tornado warning, which means there were actually tornadoes somewhere around the area. And now I can actually see the sun kind of popping out there as it's getting ready to set in a little bit. So convenient that we actually had a front pass right before the day of our front lesson.
All right, so looking at a weather map that kind of showed earlier in the day, so it's actually this morning, showing that this cold front was coming through. So what a cold front basically means is this cold air back here. You can see this high pressure, which means that air is kind of sinking down. It's the colder or cooler air was basically working its way this direction. And you can see these little triangles will tell you the direction that that air mass is moving. So on this side, we have a cold air mass. On this side, we would have a warm air mass. Now, typically what a cold front does, it's going to come and it's going to basically bulldoze all that warm air out of the way. But you can see over here, there's obviously warm air that's working its way in that direction. So earlier in the morning, they were predicting that this cold front was going to basically just go straight on through us and probably be a quick cold front, which is why earlier on that 10-day forecast, it showed it getting down to the 60s. But as the day progressed, the models kind of changed, and we'll see that next here. So this was later on in the day. So the model has now changed to showing that this warm air has actually worked its way up. So whatever was pushing that cold air down, which we'll talk about that in a little bit, no longer was pushing it quite as much as it was, and that warm air was able to start kind of winning this battle against the cold air. So you end up seeing what's a warm front, which you end up seeing these little half circles showing you the direction of that air. Now there was still the cold air being pushed down here, and over here you see this kind of weird mixture of the two. That's going to be called a stationary front. It's basically where neither one of these, the warm air or the cold air, is really winning out. They're both kind of staying still, stationary. Whereas here, the warm air was winning a little bit, and down here, the cold air was winning a little bit. So then, if you waited a few more hours and see what the model ended up showing, you could see that we have, well, the warm air is a little higher up, but the cold air has kind of taken over at this point. So at this point still, we have rain and stuff here because the air is kind of mixing with the cold and the warm, and we're getting some weather here, but we're still having this battle. We're still having this battle between the cold air coming down this way and then the warm air working its way up this way. And sitting where we sit in Jacksonville, we have a lot of these battles between them. Other parts of the country, a lot of times the cold front will just typically always win, or other places a little bit lower, the warm fronts will pretty much always win. But we sit right at an area where a lot of times, by the time that cold air gets to us, it's not quite as strong anymore, and it has a hard time pushing that warm air out of the way. So you can see that just a little bit later, about an hour or two, the warm air ended up losing out. That cold air ended up becoming the more dominant of the two. So that cold front, remember the direction of those is kind of showing us which way it's going, ends up being the one that is going to be the winner here. Which is why probably in the next couple of days, actually while you're watching this, the weather outside probably isn't going to be quite as hot as it's been the past few days. And not that it's been that hot, it's actually been gorgeous, but it's going to be a little cooler than it's been. So all of this has to do with the fact that these air masses that we talked about at the very beginning of this PowerPoint presentation video, the air masses don't really mix with each other as much as they push each other out of the way. Sometimes the warm air wins and you have a warm front. Sometimes the cold air wins and you have a cold front. But no matter what's happening with any kind of front like this, the warmer air ends up going more on top, causing there to be condensation, causing there to be rain or snow or sleet or hail, whatever kind of precipitation the temperature allows. And you also tend to see some wind, particularly with the cold fronts. You tend to see much more wind with a cold front because there's usually a much greater difference in the air pressure, which we talked about with wind a little bit ago. The bigger the air pressure difference, the more the wind is going to be moving around. So we can see here kind of a visualization of these air masses. So you can see there's almost like a boundary here where this cold air kind of stays up in the top and the warm air kind of stays down low. So this boundary, if you recall, is kind of formed by a certain global wind. If you're saying to yourself, oh, the jet stream, good for you. If you're not, well then think about it. We talked about that jet stream a few days back as being this kind of barrier, this really fast wind that kind of keeps the colder air up north and the warmer air south. But that jet stream barrier doesn't just stay in one spot. It can move around, go up and down, and when it dips down, it allows that colder air to dip down, and when it goes higher up, it allows the warmer air to go higher up. So depending on where that jet stream is, really has a big impact on where that cold air can get to and where that warm air can get to. And to kind of show what I mean, the next slide has what the jet stream currently was like when this temperature map was made. And you can see that it kind of follows a very similar, not exact, because right here the wind kind of isn't very strong, but a pretty similar kind of idea of what that temperature did. The warm air tends to be down on the bottom part, and the cold air tends to be up top. So you'll see the reason that happens is because of the jet stream. So in that slide that has the temperatures, the cold air around here was able to get much further down because the jet stream allowed it to get much further down. Whereas over here, the warm air was able to go higher up because the jet stream is kind of letting it go higher up. So I know this was a lot of information, and we're going to talk about it a little bit more over the next few days, but the idea that these global winds, all this energy from the sun is really creating these patterns that we are able to somewhat predict. And as you've obviously seen, plenty of weather forecasters and meteorologists get it wrong a lot because it's not quite as simple as, oh, it's always this exact same way every time. But there are certain patterns that we can look at. So one of those huge patterns would be, where are there high pressures, where are there low pressures? Another one that really helps us look for weather patterns is the fact that we know where certain air masses form, and we also can look at this jet stream and have a good idea of what it's going to allow air masses to do. These jet streams are really important in pushing around these air masses. And remember, even though I'm showing this part of North America, this jet stream goes around the entire planet. So these air masses don't just stop over our continent, they continue on around the entire planet and alter the weather all the way around.